Hello, today's topic is about some useful results regarding determinant of a matrix. So let's see the first result regarding determinant. The determinant of the identity matrix is 1. Determinant of an identity matrix is 1. The second result is the determinant of a diagonal matrix is the product of its diagonal elements. The determinant of a diagonal matrix is just the product of its diagonal elements. That is, suppose we have a matrix 2 1 2 and all these are 0, then the determinant of A is going to be 2 into 1 into 2, that is 4. Now come to the third one, that is the determinant of skew symmetric matrix is odd order is 0. The determinant of skew symmetric matrix of odd order is 0. The determinant of skew symmetric matrix of odd order like 3 5 is 0. Skew symmetric matrix means 1 8 A is a skew symmetric matrix, then A transpose is equals to minus A. Okay. Now the fourth one. The determinant of skew symmetric matrix of even order is a perfect square. The determinant of a skew symmetric matrix of even order is a perfect square. Now come to the fifth one. That is, the determinant of a triangular matrix is equal to the product of its diagonal elements. The determinant of a triangular matrix is equal to the product of its diagonal element is equal to the product of its diagonal elements. Now the sixth one, that if A is a square matrix and n is a natural number, then determinant of A to the power n is equals to determinant of A whole to the power n, where n is belongs to natural number. Now we need to know about this singular matrix. A square matrix is a singular matrix if its determinant is 0, otherwise it is a non-singular matrix. Suppose A is a square matrix, therefore the determinant of A is 0, this implies A is singular, otherwise it is non-singular. Okay. Now we try to understand the concept of singularity with an example. Suppose we have a matrix like this, that is 3 minus 1 plus x, 2, then 3 minus 1, x plus 2, and x plus 3, minus 1 and 2. And this is a singular matrix. We have been told that this is a singular matrix, and we need to find how many values of x in the closed interval minus 4 to minus 1. Okay, we need to find the values of x between this interval, that is minus 4 to minus 1. So we just need to find the determinant of this matrix, that is 3 minus 1 plus x, here 2, here we get 3 minus 1 x plus 2, here x plus 3 minus 1 and 2. Okay, so let's start. So the determinant is 3 minus 2 minus of minus, that is plus x plus 2. Here we get minus of x minus 1 and 6 minus of x plus 2 multiplied by x plus 3, and in here we get minus 3 plus x plus 3. These are going to be cancelled. We get here 3x minus of x minus 1. Here we get 6 minus x squared. Here minus 5x and minus 6. And here we get 2x. So it is going to be 3x minus x minus 1. And here we get minus x squared minus 5x plus 2x. Okay, therefore 3x minus x cube, here we get plus 5x squared, here we get minus x squared, and here we get minus 5x plus 2x. Therefore these are going to be cancelled, and we get here, after taking x squared common, we get 5. Okay, here it is going to be 4x squared minus x cube. After taking x squared common, we get 4 minus x, and it is equals to 0, as we have been told that the matrix is a non-singular matrix. Therefore x has a value 0 and has a value 4. Okay, but we need to find how many values of x in the closed interval minus 4 to minus 1. So in this closed interval we do not get any value of x, because the x takes the values 4 and 0, both are greater than minus 4 and minus 1, or greater than any values in the interval of minus 4 to minus 1. Therefore we have 0 values in this interval. Okay, so this is the answer, and that's all for today. Thank you very much.